Hello, welcome to this video. Today we're going to look at this interesting physics problem. So we have two objects with masses m1 and m2, and they're within a certain distance of each other of d. And let's just say they're suspended in empty space. So there are no forces, there are no outside forces acting upon them. What we want to figure out is how much is, with the force of gravity between them, how much time will it take for them to come together. So the first thing we're going to do is figure out how much distance, say, m1 is going to pass from when they begin till when they meet together. So let's say they meet at this point here. We're going to define a distance that m1 passes as x, which means because the total overall distance is d, the distance that m2 passes is d minus x. And we will try to find x with this. And so let's also define our positive direction to go this way, just so everything is simpler. And now we will look at the forces that are acting upon each one of these objects. So on m1, the force, so the size of the force, is the gravitational constant g times the mass of it times the mass of m2 divided by the distance squared. And this is just the regular, you can say, formula for the force between two, the gravitational force between two objects. But and we can say that because the gravitational force is a pulling force, the force on m1 is acting into this direction. So let's call this force F1. So F1 is in this direction, which is this in the same direction as the positive direction, meaning that F1 meaning that the force itself is just this number, no negatives, because it's in the same direction as the direction we defined the positive direction to be. And of course, so this is F1. And now we want to try and figure out the acceleration of m1. Since if there is a force, there is acceleration. And we want to use that in order to use that acceleration in order to find how much time in terms of x it will take m1 to reach this point. And then we will do the same for m2, how much time it will take it to get to this point. And then we'll know that that time has to be the same. And then we'll have two equations with two variables, t and x, and we'll be able to solve it. So we can just use F1. So F1 is mass 1 times A1. So force is mass times acceleration, meaning that force over mass is equal to acceleration. And so we have G m1 m2 over d squared all over m1. And then we can cancel out m1. And we get that this is G m2 over d squared. So this is the acceleration of m1. And similarly for m2, the size of F2, which is the force acting on m2, which will go in this direction, is the same gm1 m2 over d squared. But now this time, the direction of the force is opposite to the direction of the positive axis, meaning that the actual force itself is negative this number. So we can remove this size of, but now we have to put a negative in front. And now we can similarly say that F2 over m2 is a2, where a2 is the acceleration. And then again, m2 will cancel out, and we'll get gm1 over d squared, negative, of course, negative gm1 over d squared. Because similarly, we'll just have m2 canceling out like we had here. So now that we have these two values, we can start to figure out how much time it will take for each one of those to pass this distance. So let's begin. So if we have we also need to define the point of 0, where our 0 is in this axis. So we'll define it here, just so it's all simpler. Which will also mean that this point in M2 is D, because this distance is D, and the point where they're going to collide is X, because this distance is X. And now we can start. So this is A1, gm2 over d squared. And this is A2, and this is A2 negative gm1 over d squared. Now, to get the velocity, and with respect to time, what we can do is integrate these each with respect to t. So, first of all, let's do it to A1. So V1, let's say with respect to t, is just integrating A1 with respect to t. But this is a constant with respect to t. So as time moves, the acceleration doesn't change. Meaning that this is just this constant times t plus another constant c1. So this is gm2 over d squared times t plus c1. But we know we're saying that these two are just sitting in space. They don't have initial velocities. So in the beginning, where t is equal to 0, v1 will be 0 because it's not moving. And so v1, 0, which when we plug in 0 into here, we get c1. But we also know that they start without them moving. So this is 0. meaning that c1 is 0. So v1 with respect to t is gm2 over d squared times t. And we can do a similar process to m2 to find what is the velocity of m2 with respect to t is. So v2 of t is integrating a2 with respect to t. But now again, this is a constant in the world of t, meaning that this is going to be negative gm1 over d squared times t plus c2. But again, when plugging in 0, we know that the initial velocity is 0, meaning that when we plug in 0, c2 is going to end up as 0. So c2 is v2 0, which is 0. Meaning that this is just negative gm1 over d squared times t. So now that we have the velocity of m1 with respect to t and the velocity of m2 with respect to t, now we can figure out their position with respect to t. X of 1 x1 with respect to t and x2 with respect to t, again by the process of integration. Okay, so now that we figured out the velocity of the first object with respect to t and the velocity of the second object with respect to t, now we can integrate them both again to find what is the position of each one with respect to t in t's time. So let's begin with x1. So x1 of t, this is going to be the integral of v1 with respect v1 of t, which is gm2 over d squared times t dt. This is a constant when we're in the world of t, so we can say this is gm2 over d squared times the integral of t dt, and the integral of t dt is just t squared plus some constant. So t squared over 2 plus some constant. So this is gm over 2 over d squared times t squared over 2 plus c3. The c3, this should be in brackets, but a constant times gm1 over d squared, and it's simply going to be another constant. So instead, I'm just already going to write this like so. And now we can combine it like this and put the 2d squared together on the bottom. And now we know that the initial position of x1 we defined to be 0, meaning that when we plug in t is equal to 0, x1 of 0 should be 0. And so we get x1 of 0, which is equal to 0, but when we plug in 0 into here, we get c3. So c3 is 0, meaning that this is just gm2 times t squared over 2d squared. Now this is x1 of t. Now we can find in a similar process what is x2 of t. So x2 of t, again, integrating v2 of t, so this is gm1, negative gm1 over d squared times t dt. Again, negative gm1 over d squared is a constant in the world of t, meaning this is negative gm1 over d squared times the integral of t dt. And now we can say, again, the integral of t dt is t squared over 2 plus another fourth constant plus c4. And again, like like I did here, I'm not going to put the brackets around it. I'm already going to write negative gm1 over d squared times t squared over 2, and then add to that c4. Because just multiplying c3, c4 by this will just give us another constant, which won't change anything. So this is negative gm1 over d squared times t squared over 2, so I'll put t squared here, 2 here, plus c4. And now we know, we defined, we know that the initial position of the second object of M2 is D, meaning that when we plug in T is equal to 0, we need to get D. So x2 of 0 is equal to D. We know that. But we know that when we plug in 0, when we plug in 0 into what we get C4. So C4 is equal to D. Meaning that we can, this is D minus gm1 t squared over 2d squared. Alright. Now that we have these figured out, we can now just say this is equal to x, and this is also equal to x, because x1 of t, where t is the time it takes them to collide, is, we know it's just we know they're gonna end up in the position of x. So now we have gm2 t squared over 2d squared is equal to x, and d minus gm2 t squared over 2d squared is equal to x also. Now if these both are equal to x, we can simply say this is equal to this. So now if they're equal, we can write gm2 t squared over 2d squared is equal to d minus gm1 t squared over 2d squared. We're just gonna now it's simple algebra. We'll just move this to the other side. So all the t's to one side, and we can get t squared times gm1 plus m2 over 2d squared is equal to d. Next we're going to multiply by the inverse of this to leave just t squared. So I'll write that here. So t squared is equal to 2d cubed over gm1 plus m2. So we multiply by this, divided by this, and we got this. we simply take the square root, and because we know t has to be a positive number, because t represents time, we know this is equal to the square root of this entire thing. 2d cubed over gm1 plus m2. And that is our final result. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.